Let's extend on the idea of for loops by not using built-in functions to find the totals of everything. Sum is a built-in MATLAB function. It's a very convenient thing, but sometimes you don't have sum. If you program in C++ or something else, then you won't have a sum function. And then you're going to have to make your own sum function. And how do you do that? Well, you could do it with the loop. So that's what I want to show you now. I'm going to get rid of this stuff. Let's get rid of this stuff. I might repeat myself, but I'm going to get rid of this stuff to show you how we can do this. And I'm going to try now and calculate total mass and molar flow rates with a for loop. So I'm going to make a for loop now that sums up all of the elements inside M and N to give me my total mass and my total mole. So again, if I'm going to create a variable to hold all of the total mass and moles, then I need to make that variable outside of the loop, so that I can sum up all of the elements. What I mean is I can make a variable called mTotal equals 0, and I'm going to give it an initial value of 0, and nTotal equals 0. So before we made mTotal and nTotal equal to sum of m and n, but sum is a built-in function. We don't want that, so we're going to try to do it with the for loop. So now mTotal is a scalar, and it's equal to a value of 0 initially. Why do we need to do that? Because, well, we want to sum up all of the elements with the for loop. So let's write for. Let's make some space too. So we're going to make a for loop called I equal 1 to number of components. You agree that M is a 50 element vector, and N, the molar flow rate, is also a 50 element component, and that's equal to num components, the variable num components. If I write 1 to num components, I'm actually saying 1 to 50. And so inside this, what I want to sum up, I want to sum up the total mass and the total moles of each element inside the stream. So M, I can do that by saying mTotal is equal to mTotal plus m of I. And let me do the same for moles. So what I've done here is I've made a variable called mTotal and nTotal that keeps updating its value as it loops around. So when I equals 1, mTotal is already defined. Why is it already defined? Because we defined it on top here. So nTotal is equal to the current value of mTotal, which is 0, plus m of 1. When I is 1, this becomes m of 1. M of 1 is the first element inside M. And so mTotal becomes just the first value of M. nTotal is the same procedure. It's 0 plus the first element of N. And so nTotal just becomes the first molar flow rate of the stream. Then I loop around, and I becomes 2 now. The value of I becomes 2 because it's a for loop. Now what is mTotal? mTotal is equal to the current value of mTotal, which happens to be the previous value, plus m of 2. So I've summed up the first element and the second element now, and I store that in the variable mTotal, and I do the same for n, and then I loop around, I becomes 3, and so on and so on. So can you see that this loop is actually summing up all of the elements inside m and n, and it's doing it with a for loop. So after this for loop executes, it ends, and now I've got the value of mTotal and nTotal. So if I let me comment this out. I'm going to comment this out. Comment, just so that it doesn't run. Let me save it. What has it done? It's found mTotal and nTotal. And those are the same numbers that we got previously. But now we've done it in a way where we haven't relied on the built-in MATLAB function called sum. We've made our own kind of version of sum. that sums up all the elements inside these two vectors. So if I uncomment this now, the rest is the same. Oops, let me uncomment. Let me save. If I run, I get the same output to the user. It would look the same, but in the background, under the hood, I've made different changes to the code so that I don't have to rely on sum, and I get the same output. So that's just one way we can use more for loops to find sums of vectors. This is the approach that we would use. We'd initialize or a variable that we want to sum up, and then we would write a for loop that goes around and each time adds up the ith element of that vector. And by the end of this loop, we've summed up all elements. I guess we could also create another for loop that divides by each element by m total and then stores it in mass fraction and so on. So, I mean, for loops are very, very nice, they're very convenient, and that's just another way we can use it for our purposes. But for our sake, we've solved the problem. We've found all the mass, mole fractions, and mass flow rates for our stream, and we've gotten some experience using for loops and so on doing it. So I hope this helps. If you have any more questions, then just let me know. Thanks.